All right, this is going to be a repeat of a video that I did. Video was number 542B, and it's one of the worst videos I've ever produced. So I kind of wanted to redo it just because it's so terrible. I'm standing in front of the camera half the time, and it was just, I was trying to get the video out quick, and it's just awful. So, so this is a remake. So this is all about using your TinySA as an RF generator. It's got a lot of capability, and I've been showing the other generator that I use all the time. Oh, sorry about that. The thing's so light, it's kind of hard to pin down. I've been using this thing all the time, and you might not want to spend the money on this, or you already have one of these, so why not use it? And I mean, you can't use it with itself, right? You could buy two, but I think that's a bit silly, but you could buy two, use one as a generator and one as a spectrum analyzer. But I'm just going to say you're going to use this as a generator. And so the way that you get into the generator is to say mode, and then you can have switch to, I'm sorry, somebody's doing laundry, so there'll be a bit of noise in the background. So there'll be switch to high, switch to low out, and switch to high out. Okay, so we're going to switch to low out. So what does that mean? The low is up to 350 megahertz, and then the other one is the high frequency stuff. So we'll do switch to low out, and we get a menu that shows what frequency you're at, what level you're at, if you have modulation. It does modulation, which is really cool. And it actually does sweeping too, which is cool. So we'll have to try those things out. And external gain. So you can put in an offset if you want. That's just a mathematical thing. Okay, so we have it set to 10 megahertz. That's the default. And we'll hit on. And let's go here. I have it going into a spectrum analyzer. So let's take a look. It's hard to see, but there's the thing over there at 10 megahertz. So we'll do a frequency 10 megahertz for the center, and we'll do a span of, let's say, 5 megahertz. And there we have we'll do a peak search. So we have a marker at 5 megahertz, and we're at minus 7.12 dBm, and it says we're outputting minus 7 dBm. Okay, so let's get this out of the way. You can change the level, so let's go to minus 10 dBm, and you can see we've dropped down. We're at minus 10.28, and then you can hit some buttons here too. You can hit the minus 10, it automatically drops at 10. There at 20, 30, 40. Oops. Where are we? Minus 50. 60, 70, very nice, and it stops at minus 76. So it does that perfectly. So that's really, really good. Let's go back to maximum. Let's do set 0 dBm, and it won't go to 0, so it stays at minus 7. That's as much as it'll output. All right. So let's take a look at if there's any harmonics. Let's do a start. Let's see here. Let's do a start at 5 megahertz, and we'll do a stop at 1 gigahertz, and we'll look for some harmonics. Looks like there might be some harmonics. Let's zoom in on the stop. Yeah, there are some harmonics. So there we go. So let's take a look at those. We'll do peak search. This is at the 10 megahertz, and then we'll go out here, marker. So there are spurs at 20, 30, 40, 50. So it's typical stuff. So it's it's not a sine wave, right? It's not a perfect sine wave. Let's say it's got harmonics. It doesn't look like a square wave, but it does have harmonics. So we can see those. So nothing new there. Let's go up in frequency. Let's do a set frequency of 100 megahertz. Okay, and let's do a wideband sweep of that. And you can see we have a whole bunch of harmonics there. We actually have harmonics below the carrier as well. So let's zoom in on that a little bit. We'll do a we'll zoom in here. Let's see all of these guys. Yeah, there's still some more out there. So we'll zoom into about here. Okay. So our stop frequency is at let's make it 400 megahertz. 400 megahertz. So we're going from basically DC to 400 megahertz. And if we do a peak, we see we've got our 100 megahertz carrier, and then we have some harmonics, right? So it's okay, it's got harmonics, right? But they're down 10, 20, 30 dB, something like that. So anyway, it's got harmonics. And it's got some below the carrier and some above the carrier. I did a video on that. Okay, so let's go back here. So we were doing the -10s and stuff. Let's do some modulation now. Let's 100 megahertz is fine. We'll do some modulation. We'll say modulation, and we'll start with AM modulation. And you can set the modulation carrier frequency. So let's do that. Oops. Let's see here. It's hard for me to do this at an angle here. Just a second. Let me see modulation. AM. Here we go. We'll click it down there. I want to do 10 kilohertz. All right. So I've set the. Oops. I thought I did. 10 kilohertz. Oh, it won't do it. That's interesting. It will only do 5. How about 6 kilohertz? Oh, it'll do 6. How high will it go? I thought we would do. Will it do 9 kilohertz? No, it only goes up to 6. Huh. Interesting. All right. I thought it would go wider than that. Maybe it depends on what frequency you're set to. Okay, so let's go back to then 5 kilohertz. We'll set it at 5 kilohertz. And let's go ahead and look at the spectrum of that. We'll do frequency. We're at 100 megahertz, and we'll do a span of 100. Oops. I didn't do that right. Frequency, 100 megahertz. Span of 100 kilohertz. There we go. And so you can see that there is our modulation, our AM modulation, but it has some external components out here. Let's look at how bad it is. So it's got some lumpiness out there. Anyway, be aware that they're here. It may or may not matter. It's nice that it has it. So let's zoom in a little bit further. I went the wrong way. Let's take a look at this. There we go. So my resolution bandwidth is at 300 hertz right now. So we can see the 5 kilohertz modulation. Let's see here. We can do. Let's see. I don't remember how to do it now. Display, trigger bandwidth, trace, sweep, measure unit. Oh, here we go. Percent modulation. So it is at 31% modulation. So I don't think that's adjustable. It is what it is. Okay, so we measure that. Let's turn that back off. And let's zoom back in so it goes faster. All right. So that is our AM modulation. Let's do narrowband. Oops. Modulate. Oh, there you go. Went right back to this menu. Okay, so it's at 5 kilohertz narrow frequency modulation. So let's look at that. And that looks like FM modulation. That looks great. Let's zoom out a bit just to see if it has any other funniness going on. It's got a little bit of funniness going on. There's a what's the best word to use? It's a particular type of IF filter that's in the chip that's being used, and it has some repeating patterns in the rejection band. It has a nice fast roll off, but then it has some humps. Anyway, it's hard to explain, but you would expect things like that because of the bandpass filter that's being used. But anyway, it's doing what it's doing. Let's go ahead and change to wide FM. So you can see that the FM is much, much wider now, so we're going to have to zoom out. I probably should have looked at the deviation, and we'll do that here. So this is, we can zoom in a bit, span, oops. So it's a bit funny. It's not quite right, it's okay. But we're here with span of 500 kilohertz. So 1, 2, 3, 4, 5. So each one of these is 100. So it's about 75 kilohertz wide, something like that. Let's go back to narrow. And narrow. The narrow modulation is, let's see, now we're at about 100 kilohertz, so it's about 10, 20, 30, 30 kilohertz of modulation there, something like that. Anyway, that's what they have. All right, let's go to the, sorry about the reflections. Let's go here, we'll turn off modulation, none. We'll do sweeping, let's do sweeping. Sweeping is span. So we want to span, let's say we want to span 10, we're at 100 megahertz, so let's span 10 megahertz. And the sweep time is 2 seconds. Sweep points, 290 points, so it breaks it up into 290 points. All right, so let's see what we can see over here. So let's set this up again, 100 megahertz on the center frequency, and our span will be 20 megahertz. There we go, and we see our sweep. So we're sweeping 10 megahertz wide, so half of the screen. I can do a max hold here, so we can see that the power level is staying up pretty high. So it's very constant, so that's good. And then of course you can sweep faster or sleep slower, but this would be really useful for doing exactly what I'm doing here. If you want to sweep a filter and you don't have a tracking generator, then sweep with an external source and then do a max hold. All right, so let's turn off this. We can watch it sweep, that's kind of fun. And let's see, can we sweep with modulation on? Let's see if we can do that. Modulation, let's turn AM modulation on, and no, the sweep turned off. So I guess you get one or the other, but not both. All right, I think I'm doing that right. So what else can I say? Let's do switch to high output. Okay, so now we're going to be outputting on the other connector. All right, so this one is starting at 300 megahertz, and it goes up to, I think, 960. I think that's right. Do a preset on the spectrum analyzer. All right. I should get out my wrench, but there we go. Oops. Oh dear. Yeah, this is not. I'm fighting my cable. This thing is so light that you're fighting your cable all the time. It just keeps pushing it around. Okay, there we go. Let's turn this on. It defaulted to 300 megahertz. And so let's go take a look. And wow, it's a square wave. Wow, it's a real noisy square wave. Yikes. Look at all that junk in there. Okay, so we are sweeping from 900. Let's see. Oh, let me do this. I'm sorry. So we are sweeping from DC to 1.8 gigahertz, and if we turn a marker on, let's see. So this marker is this is the 300, and there's the it's probably 900. Yeah, no, it's 600. So 300, 600, 900, 1200. Yeah, it keeps going up. So, and those harmonics, let's see here. Let's change the reference level down so we can see everything. There we go. That's better. So they do go down. But yeah, they're very, 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 very healthy. So be aware of that. So if you're going to use this thing in high mode, be aware that you've got really high content harmonics here. Let's go back to the peak, which should be at 300, which it is. And we're getting plus 16.5 dBm. Plus 16. That's a lot. That's enough to blow up this TinySA. Good thing this SA can handle it. This thing can handle that much power. Let's see. What is the? I think it's plus 20, plus 30. Yeah, this thing will go up to plus 30. But if you were running the same thing into another spectrum analyzer, you could have blown it up already. So really be worried about that. Really should put a pad on this thing. In fact, I think I'll do that just for the sake of making sure that you do it in your testing. Plus 16 is just very, very, very high. So I'm going to go ahead and put a 20 dB pad on the output to make sure that we don't destroy anything, just in case it decides to go up from here. Safety first, safety third, whatever you want to say. All right. Now we've put a 20 dB pad in there, so we're not measuring correct, okay? But I can say amplitude, reference level offset, 20, and now we're measuring correct. Now we're measuring plus 16. Okay, so it's just a mathematical trick. All right, so let's try some other frequencies out here. This is at 300. Let's set it to 600 megahertz. And yeah, so it's just the same. Let's go back to 300. That was more interesting. All right. And we will do a frequency center at 300 megahertz, and we'll do span of 100 megahertz. And so there we go. All right. And let's change our band span a bit here. We'll do a span of 100 kilohertz. There we go. Let's move it up so we can see things. All right. And let's see if it can do modulation. Oh, we haven't done this. We haven't done the levels here. So the level says it's 16 dBm. Should have a plus sign in front of it. That's kind of an error. They really should have a plus sign in front of it. Yeah, let me show you that. It says 16 dBm. It's plus 16. It's important to put that plus in there so you know that, yeah, this is plus 16. This is dangerous territory. All right, so it says modulation, but let's see if we can do any levels. Let's see if we can do minus 10 dBm. And we can. So this one doesn't have that nice button where you press that just lowers it. I don't know why it doesn't. Why don't they use the same menu system? Seems kind of stupid. Oh well. Minus 20. It's not. They're not really measuring quite right. We're at 25 dBm. Reference of 25. Oh wait. Let's see. Not minus 18. I'm sorry. I'm measuring minus 18. So a little bit off. Let's do minus 30. All right, and we're measuring minus 31. I guess it's okay. Minus 40. And minus 38. So it won't go anything below minus 38. Okay, so let's go back and let's set it to 0. Let's do 0 dBm. I'm comfortable with 0 dBm. Okay, well, let's go back to the 16 because I think we want to have this thing running hot. All right, in fact, let's make it plus 15. Then we can measure things here. Okay. All right, so we're at plus 15. Let's turn the modulation on, narrow FM. Ooh, there we go. So it does modulate narrow FM. And let's see, marker functions. Oops. Marker over here. And let's do a delta marker over here. And so we're about 14 kilohertz of bandwidth there. Of, what's that called? You know what it's called. Deviation. There you go. Okay, so wide. Ooh, wide is really wide, so let's change our span. There we go. Let's change our markers again. Let's see here, normal marker. Let's set a marker over on that side, and we'll do delta marker over on this side. Yeah, we're getting about 67 kilohertz. All right. And that was with 1,000 hertz of 1,000 hertz tone on the modulation. Okay, so let's go and do sweeping. It allows us to do sweeping. So we're at 300. So let's see here, 300 megahertz, and we're going to span. Let's span 50 megahertz, and let's do a sweep of 20 megahertz. Let's do 20. Let's do 25 megahertz. There we go. That should go halfway across. And we have our 2-second sweep. And there we go, sweeping. So it looks really nice. We can do trace, max hold. Let's see what, yeah, it's holding up really nice. All right, so I think that's all I'm going to show in the video here. It is a very nice RF generator. It comes for free with the TinySA, so you know, you can justify buying this just for the generator. Yeah, it does have some harmonics and stuff. Yeah, the filtering isn't quite right. You'll get some out of band spurs and stuff, but it does cover quite a wide range. It does have modulation, which I've used. I've used this to troubleshoot radios and stuff. You need to inject a signal that you can hear, so you need some modulation. So either AM modulation or FM modulation. I've used both. The sweeping is nice. I wouldn't grab this to do sweeping. I like my other little board, just because it's on my desk all the time. But you certainly can use this one. It seems fine at doing that job. So yeah, there you go. I wish that the level set had the same menu as the low side. It doesn't have has the other menu part in it. But yeah, there you go. Looks pretty nice.